is on food, Foodomics, that connects food science and nutrition. And the presentation will be given by Professor Yang Hong-sun. He works in the Department of Food Science and Technology at NUS. He is a well-cited expert in food processing, food safety engineering, and of course, Foodomics. So actually, I do not know this term, Foodomics, so I'm looking forward to hear from Hong-sun.
Thank you, Nim-sung. Can you see my slide?
Yes.
Okay, thank you. Good morning, everyone. So today I would like to talk about one term or technology that's relevant to both food science and nutrition, because our department, the name is food science and technology, but we do have some faculty members working on nutrition. Okay, sorry. Before I introduce this specific, this kind of scientific aspect, but I would like to just briefly go through our department research profile. For example, a typical food science and technology department, we do have some research relevant to chemistry analysis, microbiology and safety, processing and engineering, and also human nutrition. For the specific research fields, I think you can welcome to visit our department's website. I just want to highlight one strength from our department, right? So it's more like a take-home message. So IUFOS, that is the International Union of Food Science and Technology. So this meeting is every 2 years, there's a meeting like this. And this is many of the different countries of this kind of field. We work together. So, and each of these kind of Congress, there was a kind of award that is Young Scientist Award. So most of these kind of Young Science Award are the fresh PhD graduates or like a fresh postdoc. We can see that NUS is the only university now we get 7 times consecutively of this kind of award. So each session, there's only 7 to 8 globally. So the NUS is the only one we got 7 times, okay? But of course, you may feel strange, right? Why there's a 7? Because I only choose 6. So from 2008, every 2 years, there was a Congress, right? So now this one is 2018. Unfortunately, there was no like Congress in 2020. The reason was due to the COVID, right? So that kind of Congress was scheduled in New Zealand, but finally canceled, right? And we are glad to know that this year we also get one. So this is my PhD student, just graduated last year, and now is a postdoc at the UBC in Canada. He's one of the awardees this year. So the meeting will be scheduled in Singapore at the end of this month. So we are very fortunate to be one of the best university with the highest number of these young scientist awardees. Okay, now then we can go with another one. Our department actually not just doing like publication, research and publication, but we also have very good experience that many of our students, including some of our faculty colleagues, they are good at to have a lot of spin-off companies. So then for further information, you can visit our website, department website. Okay, now I want to share some of the information, background information, right? Why in Singapore now we have more opportunities to do food science. We know that Singapore, the government announced that the 30 by 30, this vision is to grow enough food in Singapore to meet 30% of our nutritional needs by 2030, right? So not just the food, but also mention the nutritional needs, right? That's why I was glad to share that the combination between these kind of food science and the nutrition, right? So then, of course, we need more eggs, living vegetable, fish, etc. Right? Not just the raw material, but also different forms of food, and then how about the nutritional aspect? And of course, what we can do, right? So as a faculty member, as well as PhD student, for example, if you can join us, so what kind of project that you can do, for example. So today I would like to talk about this one, Foodomics. So actually, when we talk about Foodomics, actually it includes at least 4 different levels, right? For example, genomics, and then from genomics to transcriptomics, and then the upper level is the proteomics. Finally, then these kind of metabolomics. So from proteomics to the metabolomics, so that means we have different kind of individual molecules, right? So you can just imagine that the metabolomics is you can find the different molecules. For example, amino acid, and then the some of the organic acid, etc., sugar, and different kind of molecules like this. And then if we talk about food science and nutrition, then it involves, for example, food bioactivity, food safety, quality, and traceability, right? So this is just the selected aspect, but we can find that more and more of the food science and nutrition that we can use the Foodomics to elucidate what happened. And then further, we can predict what kind of possible scenario. For example, okay, you made this kind of food, if we apply this kind of Foodomic technology, then what kind of happen? For example, predict the scenario based on your food ingredient, etc. So today I would like to share with with some of the case studies we did in our lab. For example, the first one is food in vitro digestion, right? So this digestion, we know that this is also relevant to nutrition, right? So that's why I emphasize that this is connects the food science and nutrition. If we want to know if you develop a new food, right? So for example, currently we all talk about alternative protein. Alternative protein means that compared to some animal-based protein, we emphasize more on plant-based, or from algae, or from other sources, fermentation, or from cultivated, right? So cultured meat, for instance. But once we develop all these kind of new food item, one question you need to address, right? So then how about the digestion, right, of this kind of new product? So for example, so then we can see, I just want to show you one example. If we develop this kind of plant-based fishbowl, for instance, right? So then we can see that this is analog. So then you, of course, you can use different kind of technologies or biochemistry knowledge and engineering knowledge to get this kind of product. But finally, how about the digestion compared to the authentic fishbowl, for instance, right? So you need to have this kind of knowledge, especially for industry partner. They need to have this knowledge before they launch to the market, because they need this kind of knowledge to address the concern from the consumers. Okay, so then, for example, if you want to, based on this kind of digestibility, for example, in vitro digestion, so what we can do next? The next step is that we can select the right ingredient for us, right? It's not just a try one by one, but also you have this kind of theory. Okay, then I know that certain ingredient, for example, polysaccharide, their digestibility, digestion is very good for this kind of product. So then we can introduce this kind of polysaccharide to our new food system, right? Of course, one is that you need to know their combination. For example, in this kind of new food system, how about the molecular interaction among these kind of different ingredients? For example, finally, you still need to want to know that the texture, rheological properties, visual quality is pretty similar or superior than the original form, right? So you need to study more of this kind of molecular interactions, for example. So what kind of image can tell us? For example, this is an image to make a kind of cakes, right? So I think many of us, we know that cakes is a kind of snack food, right? So then what kind of expect from new consumers, for example, for the young generation? Maybe different from, every 10 years, consumers' expectation will be pretty different, right? So currently, what's the new expectation, for example? And then we may have the opportunity, right? We need to know the consumer's perspective or their expectation. For example, currently, we don't expect to have a high amount of calorie in this kind of cakes, right? So that is a kind of selling point. If you can develop some of the cakes with a very low amount of calorie, or with, for example, no amount of sugar, for instance, right? Or replace some of the flour there. So then you can attract the consumer's attention, right? So that's what we can do. For example, use some of the seaweed. We introduce some of the seaweed to replace some of the flour there. So then you can consume more, but you can get less of the calorie of these kind of cakes, right? So of course, industry partner, they have the great interest in introduce these kind of cakes to the market, right? That's what this kind of exclusive license agreement we work with industry partners. So they license our technology and then they commercialize this kind of product. So this is another one. Another one is egg product analogs. So what we work with one of the local company is a kind of AZ Cake. That's a local industry partner. So they have the interest to develop this kind of egg product analog. The reason is that we know that currently this kind of movement of the alternative protein movement, right? No matter whether you like it or not, it's a kind of trend. Many consumers, they want to consume more of the plant-based egg analogs. Right? So of course, we can study, for example, the molecular interaction, microstructure, as well as the physical chemical properties. So then we can study the new food system. For example, use the plant-based protein, and then we can simulate the visual and textural quality of the fried egg, or like a different kind of egg omelets, for example, right? But another one is that how about their digestibility? So then we can use this kind of metabolomics approach, right, to study the digestion, so in vitro digestion. And of course, we study the molecular interaction within the system. So then with this kind of technology, we can get more opportunity. So then, for example, Givaudan, so it's one of the biggest food company globally. Their major business is about the flavor, right? So they also want to launch with more of the plant-based protein business. So they work with us to how to make it more like commercially that can be served as an alternative, rather than just work in the lab, right? If yes, you can publish a paper in the lab, but finally how to get more of the business from the industry, right? To how to translate, how to commercialize your research. So some of the potential opportunity, for example, the digestion, you can see that is, for example, how about the dietary flavonoids? Some of the new, we know that flavonoids have very good antioxidant activity, right? That's why our diet, we need to consume more. So then how about their interaction between these kind of dietary flavonoids as well as, our gut microbiota? So then it could be a very interesting point, right? So then, of course, we can do further, for example. So another one is the bacteria response. We know the bacteria is pretty relevant to our food. So even though you cannot see it, right? So, but in general, we have two major categories of bacteria. One is the better ones, for example, pathogenic bacteria. Another one is a good one, the probiotic, right? For example, some of the fermenting dairy product. We want to get the benefit from it. So then both of these kind of categories, we can apply this kind of Foodomics approach to study more about this. So for example, for industry people, why they found that this kind of research is useful for them. For example, now if we study the Shirley labiatica, it's a sponge microorganism, right? So the industry partner, they want to know, okay, why any heating or non-heating processing technologies, you can control this kind of spoilage microorganism. And the last time, whether we can use an easier approach to control this kind of spoilage microorganism. Of course, then the industry people, they'll find that it will be very interesting, right, to know more about it. And this is about, for example, flour. So flour can be contaminated by some, for example, E. coli, right? So we know the E. coli is a pathogenic bacteria. For example, the new big 6 E. coli. So if we get this kind of flour get contaminated, so then finally maybe the people, if you consume this kind of baking product, you may get disease. So then, of course, industry people has a great interest to know more about it. So I just want to skip it. This is just different examples of why we can use this kind of integrated approach of the Foodomics approach to know more about the food science as well as the nutrition, right? And then this one is, for example, if we apply just the essential oils, so it's more like a natural product. We do not need to resort to different kind of like chemicals like chlorine, right, to control the bacteria. We can use the essential oils, for example. This is more natural, just from plant, right? But then how about their mechanism in killing the bacteria? This one is a different story. It's about probiotics, right? So we know that dairy products, one big category is, for example, fermented milk. Some of the fermented milk we have introduced with some probiotics, right? Probiotics, why we want to have it? Because it can promote some of the gut microbiota within our body, right? Promote the growth of this kind of microbiota within our body, and finally, it will be helpful for our health. So that's why this kind of probiotics is also a very good target for us to know more about it. For example, if we want to change the recipe of this kind of fermented milk, how will it affect this kind of probiotics? For example, some of the lactobacillus, this kind of category of the bacteria. So if it can promote this kind of growth, so then it will be good, right? So we can get a higher amount of this kind of probiotics within your fermented product. Yeah, I think why I share this one is that for PhD students, okay, if I were a PhD student currently, for example, to consider the graduate school, maybe I can consider there are two approaches. Finally, for example, if I want to receive the PhD training, one is to do more like basic science. You need to, yes, I work on science and then publish paper to be famous in the field. Another one is that more like applied basis. You know, the food science and the technology is one advantage is that you can have both training, right? You can receive this kind of both training. So finally, for example, after you get a PhD, you don't want to continue within the academic field, so you can work in industry, right? And you can found the startup companies. So I would like to share that why I have this kind of idea, that develop this kind of idea, that work with many industry partners. So this was actually started in many years ago where I was a PhD student in Minnesota. So actually there was a grant call from PepsiCo. They received a lot of proposals, but finally they funded my proposal. One of the reasons is that my proposal is not just focusing on fundamental science, but how to collect this kind of fundamental science to finally the application in industry. So this one, they want to know about a serving science of fruit and vegetable. So my approach is pretty different from many others. My approach is that to convert different kind of science, different kind of parameters, finally to a mathematical equation. So then the industry partner, you only need to use this kind of mathematical equation. You just put input and then you get output. So we only need to control the output to be stable, right? So no matter what kind of different input, you change a lot. For example, different seasons of your fruit, vegetable, and the different storage fruit and vegetable, whether it's cold storage or the frozen. So you can only control the output, then you can maintain the consistent quality of your output. So I just skip this. So currently I'm still one of the members of PepsiCo Open Innovation Team. And I'm the only member from Asia. So they have around 10 members globally. So I'm only a member there from Asian countries. So you can see that industry people, they also want to hear feedback from our academic, right? So academic and industry is not just totally separated from each other. Another example is that I work with the Wilmar. So the Wilmar, you know, the headquarters is actually in Singapore, but they have the big R&D team in Shanghai, China. So I work with them through the NUS Research Institute in Suzhou, so to solve some of the technical questions. And some of the potential application, for example, today I introduced, for example, the Foodomics, right? So when we talk about any of this kind of scientific term, so when we work in food science or technology or in nutrition, you can consider that what kind of potential application in industry. So then finally you can talk to industry people, okay, this one can be very useful for your business, right? So then I think they will be very happy to discuss with you further about the collaboration. For example, here, we know the food protein can have this kind of aggregation. For example, if you have infant formula, and then for example, stored for 1 year, what happened for this kind of food protein? They may form aggregation status, right? And then affects the solubility, right? So we know it. But then what happened, for example, can we introduce this kind of new technology, for example, Foodomics, to know more about this kind of reasoning behind, right? The science behind. And then you can talk to industry people, then we can solve this kind of issue in industry. And just want to share that some of my PhD students, they got this kind of award. IFT is the American Professional Society in Food Science and Technology. This student got the first award, right? So of this kind of division of the graduate student competition in food microbiology. And this student, another student is in aquatic food products division. Both are the first place of this kind of award. So of course, I made some other students, we encourage our students to go to abroad, right? To attend different scientific meetings, to compete with peers globally. So today, I just talk about the Foodomics. So then they collect with the food science and nutrition. I just use some case studies. So then one is to collect the food science and nutrition. Another one is that how to collect our basic science as well as our applied science, how to link with industry needs and then work with industry people. So then you can see after graduation, you have more roads to go, right? Or more career paths. You can consider academic paths or non-academic paths. Maybe you can find a business with industry, right? So that is more like I would say transnational research, especially in our department. We emphasize a little bit more than some other universities. Okay, here I just want to acknowledge some of the supporters from industry partner as well as some NIF, for example, the government funding agencies, as well, of course, my students. So many of them, actually this photo was taken a couple of years ago, right? So many of them have graduated. Yeah. Thank you very much.